Well, hello, good morning, good afternoon, or good evening, depending on when you're watching this. That's up to you. Today, second to last section of this chapter, we're going to deal with angle measurements. Okay? Now, angles can be formed inside the circle or outside the circle. And we have two general formulas to deal with that. The first, if the angle is formed inside the circle, it is formed by intersecting chords. Okay? We can deal with these angles. Remember, they're equal because they're vertical. Or these, same, they're vertical, therefore equal. Okay? And we can be asked about one and given information on the other. We'll get through that. I've got the examples for you. Now, if it's inside, the measure of the angle is equal to 1/2 the sum of the arcs. Add the arcs together that are intercepted, divide by 2. So for this angle right here, or this one, add this to this, divide by 2. Okay? Like that. So if the angle's inside, we add the arcs. Pardon me. Now, there's two instances where it's outside. If they are intersecting secants, okay? If they're intersecting tangents. If you have a tangent and a secant, all three are the same. Okay? If the angle is outside, we subtract the arcs. Large minus small, divide by 2. Okay, so in this case, I would take AE minus BD, divide by 2. That's the measure of angle C, right there. Okay, same thing here. But I want you to notice something important. When you're dealing with two tangents, okay, when you're dealing with two tangents, you are dealing with the entire circle, all 360 degrees. Okay? We'll see examples of that. I've got a couple of those for you. Okay? So, let's go to the examples. Okay. Our first one, and I kind of made it so you can't read half of this. So here we go. Find each measure. Assume that segments appearing to be tangent are tangents. That's important for us. Okay? So here we go. First thing, we look at what we are asked to solve. We need to find the measure of angle 1. But I want you to notice here that for this example, I didn't give you the proper arcs. I gave you these two, which would deal with either of these angles. This is what we're going to do. We're going to find this angle. Remember, those are supplementary, so all we have to do, once we find the missing angle, is subtract from 180. Okay? Another way to do it is to realize, if I add these together, subtract from 360, I already have the sum of those arcs. So either way is going to work for you. Okay? So here we go. Let's walk through it. Okay? I'm just going to find this right here. I'm going to call it x degrees. So the measure of angle 1 is 79 degrees. Okay? Not difficult as far as the math. Once again, I say this every week. The math itself is easy. Just make sure you put things in the right place. That's what you got to think about. Okay. Now, we have an angle formed by two secants that intersect. We're going to take the large one, subtract the small one, divide by 2. Okay? Okay, so you've got measure of 31 degrees. Really? Just get yourself a calculator and go to town here. We're good with that. All right? Once again, gravity is working. Pens are falling. Everything's coming together. Okay. Here's an example of a tangent and a secant intersecting. Okay? Tangent and a secant. So, I'm going to do this. I'm given this arc, but I need this arc for this angle. So, I'm going to start by subtracting 134 minus from 360. Okay? And that's going to give me this arc up here. Okay? So that's 226. Now, this is half of that. That's just like an inscribed angle right there. Okay? Okay? Same thing here. We treat these just like inscribed angles, okay? That's the easier way to look at it. Okay, once again, I've got 216 right here. That tells me that this over here is going to be, let's see, what is it, 144. Okay? 360 minus 216 is where I got the 144. Now I'm just going to take half. Okay? Okay, yes, you can still see. Okay. Now on this one, I'm given the angle, I'm given the large arc, I have to find the smaller one. We start with the same formula, folks. No difference. Okay, so in this case, it's angle equals 1/2 large arc minus small arc. Angle equals 1/2 large arc minus small arc. Okay? I'm going to clear this by multiplying both sides by 2, moves the fraction out. Okay, you have a choice here. Subtract this, okay, and you're going to have a negative equals negative, still going to be positive, or you can move this over to make it positive, subtract that there. Both will get you the same answer, as long as you do the math correctly. Okay? So, okay, and here we go. Once again, I have an angle formed by a tangent and a secant. I have this right here is 62. I can find this, okay, and I need to find angle R. So think for a second, what do I have to do? I have 62 degrees, I have 116 degrees, I need to find this. Add these together, subtract from 360, okay? See, that's what I did right there, okay? So the first thing you do is that, and you're going to get 186 right here. Okay, that's where I got it from, just so you'll see it. Then it's going to be angle R. Okay. Whoops. Six. Good. Yeah, we're good. Okay. So we now go over, yes, you'll get pictures of these, don't worry. Okay, we'll go over the other board. Okay, a few more questions to go. Okay, these three are going to be much the same for us. Okay, find the angle. We have two of the arcs. Okay, so that's just going to be the measure of angle Y. Okay, here. Two. So the measure of angle Y is 21 degrees there. Okay? Now, here's one of the ones I was telling you about. This is the arc we need to find, but we don't have any arc measurements that we know of. So we have to represent them with variables. Okay? So here's what I'm going to do. I'm going to call this arc CE X degrees. Okay? Which means the rest of the circle, okay? I'm creating a formula here. So the rest of the circle is going to be 360 minus X. And that will work for whatever degree measure we need. Example, if X is 100 degrees, 360 minus 100 will be 260. There's the whole circle. Okay? If this was 90 degrees, 360 minus 90 would be 270. That's why we do it. It's going to represent whatever number comes into play. Okay? So now I'm just going to set up my formula. No, I didn't mistakenly write minus X twice. Remember, that's the large arc. That's the small arc. Just like I did when I substituted numbers. Okay? You have to represent both of them. I'm going to multiply both sides by 2. Okay? Don't have to because they're going to be even over here, but. Okay, so here we go. 4, 6. Okay. So what I did was I moved the 2x to this side to make it positive. I subtracted the 104 right there. Okay. Divide both sides by 2. Okay. Same principle, only in this case I need the large arc. I'm going to use these exact same representations. There's my x. There's 360 minus x. 37 is there. Okay, now, here's where you have to be careful. Because we solved it the same way and found, oh, okay, I got that one. What I found here was x. But remember, the problem wants this. Okay, so I do have to find out what that is. So 360 minus 143 is 217. Okay? And our last problem. Okay, it's a word problem, but it's going to give us the same basic concept. It says, in a game of kickball. Remember that back in elementary school when nobody had gloves, you kick, yeah, okay? So in a game of kickball, Ricky has to kick the ball through a semicircular goal, okay? If the measure of arc XZ is 58 degrees, and the measure of XY is 122, what angle must Ricky kick the ball through? Well, that's what we're looking at. Okay, so that's all we're going to do. Large arc, small arc. Remember, it said semicircular, so that means that's a diameter. We don't have to worry about the rest of the circle. Okay, so Ricky has to deal with a 32-degree range to kick the ball. That's it. Okay, once again, I keep saying this and I keep harping on it. The math itself is pretty easy. Just remember to take a second, put the numbers in where they need to go, choose the correct formula, and go from there. You're going to be okay. Okay? I will see you next time I see you.